And the screen sharing, that's fine. Okay, so the last time we have been implementing a a file transmission system to our messaging client, but we did not finish it, so we will look now into finishing that functionality. We need to prepare our terminal so that we can start multiple instances of our client. Zack. And let's see where we left off the last time. So GUI message of one day, send file, right. So we have here our send file, which is not yet started. And if I recall correctly, the idea was that we will use the chat manager to start a new file transfer. Can get a session, send file. So let's invoke that. So enter chat manager. Zack, send file. URL we will need to get, or for now we could make it really simple just by taking the already existing file transfer input. Later we can improve that with getting the current URL from the currently selected tab. Okay, so we have file and file name. Send file. Right, so let's see. We have create a new session. Insert it. We start this. When we create a new session here, we need to take a look into the implementation to ensure that we will be starting a file transfer. So we have here the other option, which takes a file name in the constructor. So then we have file name, and then we need to start, which should be, okay, here needs to be implemented as well. Start URL. Don't provide a name. Start will start the connection, and then at some point in on connect we will see that we have a file name and send a communication request. So here we could go to the function which passes that and put a breakpoint. Now when we run it, we expect when we start a second instance from here, then we will be able to enter the breakpoint on our debuggy side. And that's that. So instance 1 is the other one. Here we have our debuggy menu. Right, we need to start new chat first. Send file. Just send the config file and to this client. Okay. It's not yet working as it should. Let's see why. So one thing we could try, of course, is we can try to send a communication to ourselves. Again, so we select some file. Doesn't matter which, and it doesn't do anything. So let's see what we have missed from the last time. So we have our chat session. We have here our start communication, and then we should enter here our on connect. So chat, send file, message 0, connect to our own port. So we have the URL, don't have a name, we start the connection, and it does not connect. Does not connect at all. That is not great. Let's see if the actual port is still available. Message. Socket, well, we are listening on the port, so that should not be an issue. So let's quickly add here some debug information. We want to see what's failing simply by looking which URL we are trying to connect to it. Usually should work just fine, but apparently we have forgot something. So here, when we URL is empty. Okay. Then we have on connect twice. Then this is odd that it works at all. Let's see why this is behaving so unexpectedly. So we enter here, and apparently we have an empty URL. When we go to our start instruction, we start here. So we should have a URL which is not null. On start, we have another URL. We might have small mistake here. We have to first, of course, assign the URL. So it probably was just fine. And output, right, we get the right address here, so this is fine. You have one on connect event and then another one, since we always have two, and then we try send file with some random file. Right, okay. So somewhere we are not passing the URL properly. Target, oh, that's the problem. We need to create a proper URL first. We cannot pass just the like we did here. We cannot pass just the string. As we could if we would have reformatted the string to be an URL, but we want this to behave more or less the same. So we'll quickly here implement it in the same way. As said, this is just temporarily. Once we continue with our implementation, we'll just be pulling the URL from the current open chat. And I think we don't need this breakpoint anymore. I am confident we'll get a connection to succeed now. And we do. So let's see what we connected to our file session slot. File session. The on file session. Right, so we create an entry. We emit a file offered. Let's see what is now connected with this. We have nothing connected with it, so we will need to connect something so that we can then accept the file offering, and then we will continue from there. So simply copy the right string from here, and in our main window we will want to have a slot void on file offered. Here we see the file name and file size and the chat session, so all the data we might consider relevant. Of course, we still need to connect it. Put a breakpoint here. Here we have some of the sessions. Here we have some more chat manager. Chat manager female offered on when the IntelliSense doesn't work, then we just do it like this. So let's try again. Now we expect to end up, I think I didn't set a breakpoint, in our function, in our slot. So I set the breakpoint, so perfect. We will end up here once we try to send the file. Yep, and we have the file name, although we have the full file name, so we might want to change this to transmit only the file name itself, not the full path. Then we have, of course, the file size, which shouldn't be 0, so there might be an error with that. And then here we get our chat session, so we have the user, and we also have the socket, so we could verify whether the user is the right one. But first, let's see why the file size was not properly transmitted. So we'll go to our chat session, and we'll put a breakpoint here, and where we send it, here we'll also put a breakpoint. Ideally, we should grab this separately. So now we can see whether we get the right file size and we just don't send it, or whether it is a parser error. Further down, chat, send file, and we select something that's not null, so that we know that we expect to get something. This was read properly. Then we'll have file name, vertical bar, file size, so that should be correct. That looks correct. Params also has 2 params. Oh, that's a typo. This should have been 1, otherwise we have been trying to parse the file name as the file size, so we can, I think, rely that this will work fine. So let's continue here. There are a few things which we should not forget, namely that we want at some point to move the sockets to own threads, but we can do that only once we really start transferring the file data. So here first we'll be making queue message box question, this where we will be prompting the user whether he wants to receive the file or not. Right, we should translate everything. File name and file size, and we should also somehow add information who is sending it. This of course is not quite safe, because anyone can claim to be anyone. We don't have any validation now, but we can add this later on. So here we now write the prompt, %3 %1 1 2 comma question mark. So we make an if this is before we finish the first I need to specify what buttons we want to have. Q message box. Yes. And no. So if this is not equals yes, then we just return. Although we should probably not just return, we should notify the sender about that. So chat. We could just close the session without sending anything back, which is probably fine enough to and of course the other option when we want to receive the file will be to show a dialog which will be prompting the user to provide where he wants or she wants the file to be saved. File name, save file, get save file name. Again, if this is null, the user could change their mind later on, so we cancel again and return. But if everything was fine, then we say like here accept file. This function does not exist, we need to add it, and we provide the file name where we want this to be saved. So we go back to our function here. As you remember, we had a we have start, and here we specify the file name. So now we need to make a function somewhere here. Accept file. It just takes the file name and will do a few things. So we place this above close, although the order is not that important, but it's nice to have the same one. So here we will want to send control, and we just send accept and an empty argument. We don't need to tell the file name to the sender. What we should do is we should change our own file name to be the file name that we accepted. So this we should do it in this order, and then we also should somehow set a flag which notifies that the file has been accepted, so that someone could not just start sending us a file and we would think, okay, we have probably accepted, so let's go. And this will also be reset once the file transfer operation starts. So we send this to true, we send a control of accept, and then the on-control slot, or rather the on-control message handler on the other end will see that it got this accept command, and then it can start sending the file payload. For a quick implementation, we can for now start just doing it in the current thread, which will just lock down the UI. But probably this will not work with one client sending data to itself, because it will be locked down and will not be able to do anything. So either we would need to test this with 2 clients, or we would need to go for a multi-threaded approach from the get-go. So I would say we will try the multi-threaded approach. So to do that, we will need to create a new thread, move this whole chat session into the new thread, and then there let it run. So let's use the existing files for that. Ideally we should only move the socket itself. This will be more fail-safe. Let's try with that. So say async session public queue thread stack the async session parent and we will need to move we'll need to run it. So we might need that, we might not, we will see. Just have to check whether the default implementation of run invoke exec or not. Well, I don't see it here. We will just put a breakpoint and test it. So accept that. Right, so chat session. One thing of course to take into account is that we want to make sure that we will not try to move it into a thread if it's already in another thread. So we'll have here a test. So if this is null, then we do something else, we don't do anything. Then right, that might also be a bit problematic since we are in a message handler, so we will use a queue timer single shot this comma 0 comma so the queue timer single shot schedules an event to be executed in the current thread, but it should not do it within the current call stack of the message loop, but once it returns back to the from the current place where it is. So the reason for that is that we really want to avoid a scenario where our move to thread will not work properly. So we make this, we have pthread, and now we can np socket move to thread pthread, and now everything that's further done with the socket should happen in that thread. I'm thinking if we could somehow make this not needing a thread, we might be able to. Let's quickly comment this out and try to do it in the fully asynchronous way, as in theory should be possible with Qt. So for now, maybe just let's comment this out. We might want to come back to the idea later, but for now it could be doable. So as said, we received the accept instruction, and what we will want to start doing now will be to start send file, and this would normally be in the new thread and run completely asynchronously, but what we can try is to use the message.mechanism to implement a asynchronous behavior without explicitly using any additional threads. So that would be quite nice if it works out. So we will need to connect for that to a few more slots. So we have here a on ready read, and there is another slot which we will need. Can quickly, that was the wrong place. We can quickly see what other slots we have. One that is triggered whenever data has been sent, bytes written. So the idea will be that we will just try to send a small portion, and then we'll just completely exit from wherever we are, and then we will wait for some data to have been written, so there to be a new empty space in the buffer, and then we'll send the next block on bytes written. I think this will be in the end a much more elegant solution, as it fully utilizes the facilities which Qt is offering us. Do we connect to this somewhere else? So we do all the connection from here. Perfect. As mentioned earlier, we still need a separate thread, since otherwise we would lock down the current communication channel, and no more text communication would be possible, so this we would not want. So now we will need to start reading the file. So we'll open a file, and we will need a qfile mp file, a file which we will be reading and writing from. So mp file is this new cool file. We can pass the file name as argument, if I recall correctly. Yeah. Oops. File name, comma, this. So we have a file on the sending side, and now we will start sending data. So mp socket write, and the question is how much we write. So it would be good to try to write as much as we can and then break out of that. So, and also of course we will need to somehow notify the other side that now a file is on its way. So we will send first another control message, which will contain we could either send just a control message telling that we start with the file data, or we just start with the file data and expect the other side to understand it. Let's do it this way. This is simpler, but we will still want a loop, so that we can send multiple blocks and only break once we are not capable of sending any more data. So let's make let's send our file in 4 kilobyte chunks. So first we need, of course, to read the file. Read. Can specify a maximum length and where to read to, command, and as a return parameter we get the count of bytes which have been read. So if this is null, then we are done. And now we try to send some data. So here again we'll be just using buffer to be just on the safe side. Let's say if this is less or equal 0, because there can be an error which would be -1, in which case it would also break. So buffer and read, and then here it will tell us how many bytes it was able to send, which might be less than what we read. So if send is not equals red. Well, the two things. So first of all, so what we want to do now is, if we have sent less than what we could, there are two ways. Two things which we could do. One is to keep the data into the buffer and then try next time from wherever we send it, or the other option would be to move the file pointer back to the position where how much we were able to read, and then start reading again at this offset. I think it would be more elegant to actually have a file buffer here. Oops. And so we will just do it this way, and we can slightly improve this. So buffer.reserve. Actually, we could resize to the right size, then buffer.data.size. Then we read something, then we can resize again. So first of all, if less than 0, then break because an error, else resize to red, and if size is or is empty, it's better. Is empty, then break. So here we can just write the buffer. We have our red, which is fine, and now at this position we will so of course if send is not -1, send is more or equals 0, then actually technically just if it's more than 0. So buffer punct remove index 0, comma length will be amount of send, and we will break, of course, because the next send will also not work until the buffers were cleared. And here one more thing we need, we will move this to be separate. The resize we can do, and the resize we leave here. We set read to be 0, and then we first check whether this is not 0. So if the buffer is empty, only then we will try to read something new. After here, and if the buffer is not empty, so we could actually maybe change the order here. If not empty, then read is equals buffer punct size. Where do we use read? Here, and actually that could be even more elegant if we do it like this. Then we don't need to store this variable. Right, so we only read the buffer if we don't have any data in the buffer yet. We try to read 4 kilobytes. We adjust the buffer. If we haven't read anything, then we break. And here we try to send as much as is in our buffer. If we didn't send the right amount, then we check if we sent anything, and if we send anything, we remove what we sent from the buffer so that we don't resend it, and we break in any case to give the other side time to receive the data. And then, of course, one more thing we need to do is here we need to create another function, continue send file. And actually we'll be breaking this into two functions, because as far as it looks, we just need to open the file here, but everything else can be done in continue send files, and this will also then be triggered by onBytes written, assuming that there is a file open. So if file, and we've written some bytes, this means that there is a new room in the buffer, so we can try to send the next portion of the file. And I think I have a typo. There was a small typo in file name, in the function name. Right, and once we are done, then we could also get rid of our file objects. So in principle, realistically, we will be running in this loop, in this continuous send file loop, as long as there is anything, and we'll always have something in the buffer. We will never exit this loop with data in the buffer unless we are done sending. So here we can have a check that if file buffer is empty, then we can delete the file and delete the file and set it to null, because we are done. Also, since we are done sending the file, we could close the connection outright. But for now, let's just keep it open. We might use it for something else. We are the sending party, so it would be good if the connection would be closed by the receiving party, since we might want to add some error correction or something like that. So we will want to make the other end have the opportunity to check the file and then to tell us if they want something to be sent again. Also, I'm pretty sure we will need to add here some control code. For now, we just did it without it because it was more expedient. So we have we remember that we have set the accept flag, so we can go back to our onReadyRead. We always add data to the buffer, and if alright, so we have here our onControl. So if file accepted, if we read a file accepted message, then we should break out of this loop. In any case, we should not enter this loop as long as file accepted is set. So ideally we want to have first an if is not file accepted, and here if is file accepted. We cannot use an else since this value may change by this thingy. And on the accepted end of the file, now we will be saving the file to disk. So here, if the file got accepted, we could do a few more things. We could again open the file to write to. Oh right, we forgot to open the file, by the way, for reading. That is a small mistake. So file open q file read only. Right. So here we will make write only. No, not here, but there. So we open the file, we write only, and here now what we can do is we can just write everything that's in the buffer, that's left in the buffer, so to say, and clear the buffer. Since we always write everything, we don't have any expectation of write failing unless maybe the hard disk is full. So we might want to add error handling for that case, but it is not a expected common scenario. So let's put 2 breakpoints here and there, and then try if it works out. We should probably use some file from our debug directory so that we don't mess anything up. And we have a bug somewhere. Right, we already have a file name variable. File name, local file name, or save file name. Actually, we can just reuse file. No, we cannot because it's const. Yeah, let's just stick with save file name. Right, so we start a chat. We try to send the file. We said we want to use a file from this directory, so let's quickly copy the directory here. Let's go with something big like this PDB file. Then we want to send it to this target, and now we ask whether we want to receive it. We say yes. Let's give it a new name, messenger PDB2, and this we accept. Then we get here, we open the file. At this point the file should already exist. We have it, right? It's 0 size, nice. Now we continue, and we get something in the buffer which was empty, which is okay. And it doesn't work yet. We have a deadlock. We have a deadlock, so probably our send routine is not terminating ever for some reason. Let's put the breakpoint here and see what happens. So we have already data in the buffer, which was to be expected. Apparently it's the file as is, so we have not sent anything. We have our socket, we have our buffer, we try sending and we get 4 kilobytes, so this is okay. Then this should not be... Oh, haha. Sure. If this is the same, then we want to clear it. Oops. We forgot about the successful case. Let's quickly delete our test file and rerun it and see if we will need to select the folder again or whether it has remembered. So Windows usually tries to remember folders, but I'm not sure if Qt implemented that properly. So yeah, they didn't. It always starts in the working directory instead of loading the right directory from the registry. We might want to later just hardcode the path for testing or something like that. Well, it's doing something. Don't see how large the file is. We could inspect using our task manager. Where is it? QMessage files. Right, so let's go with file name pdb. Okay. Well, the second file is still open, but other than that it looks finished. So let's close the handle forcefully. Well, it's almost done. It was missing some data, so let's see. First of all, we need to know when we are done writing to the file, and since we don't have like control codes, we will want to add at least some things, as I mentioned earlier. So here we will add a control code to be file data, and as argument or just data, we could just call it data. And this argument will again send the size, just to be on the safe side. Though we had the size once, it's better to be sure. Also, we could now take the size as we get it from the file, in case the file was written to in the meantime or something like that. So we have now the reliable values. Data of size such and such. Then we will need to save this value for later. So here we have file name, and accepted that we don't have file size. So let's add this quickly. File size. Now let's go with file data. Control file data. So we have accept. Then we have here file data. And we'll also change another thing. I will add another helper variable. We have file accept, and we will have file data file data pending. Right, so if not, oops, if not they call that other one file accepted. So if not file accepted, then close. That's a protocol violation. We are not supposed to receive file data if we did not say we accept. Now we can set file pending to true, and we can move some of our receive logic there. So where were we? Right. So if we accept and we have file data, then we open the file and save, and then of course we need to get the file size and save this as well. So we are passing here the parameters, even though we are only using the 0th entry, just in case we want to add more entries later. That gives us some additional flexibility. U file size is equals param 0, and maybe we should move this to the end. It doesn't really have a functional difference, but just looks nice if this is the last one to be set. So now we know how much data we expect to receive. Here we have our file data pending flag, so now we will repurpose the accept flag. So here we'll just use file data pending to break, since we already have set up the receiving. Actually, that can even be made much more elegant by doing it like this, so we don't waste lines of code. We just put the check into our for loop, and then here we have our file data pending. So we always write buffer, we clear the buffer, and if file size is equals mu file size, then we can close the file and exit file receiving. So close, delete, null, right, and file pending is false. So now we would be ready to receive some other data. Good. Good. That should be fine. Then we could start it, and now the expectation is that we will properly close the file after it has been received, and then since we are the receiving party, we can close the connection. Okay. New chat, send file. Right, we have deleted the other test file already, so let's go. Oops. So let's go where we want to grab our test file from. Of course, the next thing to add will be some progress dialog. That would be quite nice to have, so that we see what the sending is doing. Because now, basically, we don't know what is happening inside. We can just take a look here. And, well, we are saving the file, and now it's closed, so it should have the same size, and it has. We don't have a comparison tool, but I would assume it should be fine. Let's just delete it. Okay. So as you see, our file transfer already now is transferring, even though there are very many things yet not implemented, like error correction, etc. So here, for example, the idea is that at this point we could send like so first of all, before we close the file, we could check its integrity, and then we could send some request for some error correction data or something like that. So there are things which we could improve upon, but for a very basic implementation that already is a working file send mechanism. The most missing thing now would be, of course, to make it more convenient to use and add this progress dialog. So we could, first of all, so one thing that we wanted to do during this lecture, as I mentioned last time, is to implement the close button so that we actually can close chats and do things like this. So I think we might want to do this next. On session closed. But first maybe let's finish the file sending, just in the sense that we would like to have this behave more convenient. So we don't want to have to specify a target again. So we could go with picking the right object from our tab. So here, get rid of this, and now we need to the index. So chat widget. Here we can just go with current widget, and from this one we should be able to get the URL. Get URL no. First we need to get the session, and then we can get the URL. Okay, so first quick improvement, and when this will be fine, then we see what we do next. Okay, start chat. Pick a file again. We accept it this time. As you see, it didn't ask us where to send the file because it's automatically picking the right, the open chat window, which is quite nice. It's still transferring. I see one issue here, that the memory spiked so much. So I think what is happening is that we are reading too much data into the buffer. We should fix this before we continue. File, continue send file, and here we have read. Although that might also be the buffer of the socket, that this one is unlimited, because this looks correct. Right, so let's first do the close, and then we'll continue from that. So do we have the close request already? No, we don't. Or maybe close. So we need to implement the onClose request. So this slot will be triggered as soon as we click the close button on our on any of the tabs. I will move the close request to be close to the on tab changed. On close requested, close requested. So let's first check whether the slot is connected properly. It's not. I already see it here. We need the right name of the signal which we want to respond to. Okay, and now when we try to close any of those, it doesn't do much, but at least it tells us we want the connection to be closed. So as you will see, it's not quite difficult to finish this. For once, of course, here we grab the message, so we can get session close. That's one thing that we want to do. The other one will be to remove and delete this element, so delete later. And one more thing we will need is to remove the remove tab at index index. So now if we close it, then it will remove the tab which we closed. It will leave the other tab open if we connect it to ourselves. So we can quickly try this out. So now, as you see, we have two open connections. They are indicating that the connection is still well connected. And if we close one of them, the other connection closes and gets disabled. Then we can, of course, again start a working connection, and we can close it. I closed both. That is not good. It should only close one of them. Apparently we have I think we had something with indices, didn't we? Forgot no. This is fine. But we definitely should in any case remove an entry from this map that once it's closed it should be gone. Move chat session. Punkt data. Oops. I'm not sure if this will be all that's needed. In principle, that should be fine. Nope. We have some issue. Right, session value sender close. Are we removing the wrong entry? We might be removing the wrong index, but I don't think. Oh, sure we are. Copy and paste back widget index. We have been removing not the right entry, and then the whole thing got a bit confused. So now it should be fine. Zack, we close one, open another one, we close one of them, and sessions was 0. It might be the case. Do we only add sessions if we chat map? If we create an on start chat, and here on info change, write on close request on start chat. Might be adding tabs in multiple places. Add tab. Chat map. Nope. Okay, something is broken. It will need some more debugging, so we will just put a breakpoint here so that we see what we are doing. Do we actually remove things somewhere else? No. Okay. So we start a chat, we close one, so we enter the function here once. The map should have 2 entries, and it has. Now it should have 1 entry. That was normal. We had another one, we closed the other one. Now we should have 3 entries, we have. Now when we try to close again, map has still 2 entries, which is fine. Something about our close call is not working as it should. Session closed. Okay, so we here, not quite here. So we said we want to close the existing session, and at some point further down the line here we get the sender again, and apparently the sender does not have a, and sessions is now it's in chat manager. I think we are just adding sessions which we created, but not sessions which were incoming. Start chat, send file. Right, the sessions are getting close, but we are keeping the reference. So we either need to disconnect the close socket, or we could, for simplicity, just when the issue happens here. So if it's null, then just return and say that there was nothing to be done anymore. I think this is a good enough solution. We could, of course, alternatively disconnect the closed socket once we remove the session and only keep it referenced in the UI, but I think this is not necessary. Alright, from the breakpoint, now we add another one, zack. Yep. And when we remove, of course, the last one, then we don't get the empty page back. So this is working. And as I mentioned earlier, since this close button was one of the earlier homeworks, after today, of course, it's too late to submit that particular homework. And since, again, we run through quite a bit code very quickly, I wanted to ask you if you have any questions about the existing code or about what's next. You might have noticed that the next lecture will be the last before the Christmas break. So I think during the next lecture we should think of some final project for you, so something that you could implement on your own. Yeah, but first let me know if you have any questions before we keep going with the next part of our file transfer mechanism. Okay, if no one has any questions, then the next thing which we will want to have would be some mechanism to show progress. And I think to implement a progress dialog as such would be a good homework for you. So what we would want to do here is just implement a core mechanism to show a progress in some way, and then show the progress in the status bar. So it will not be cancelable or anything, but we'll see what the thing is doing right now. The downside, of course, of this approach is that we only see the progress of one thing, so to say. We could just so the status bar, as you might know, can have multiple widgets where information are shown. Our current window is using it just to display ready, but we could have multiple groups, so we could pretty much add one group for every file operation, and in it display the current progress. So I think we'll go with that, and then we'll remove those groups once we are done. So let's see, we will go to our chat session. and we will add some signal again which will indicate the progress. So void avoid transfer progress. It will take a int progress, or we could actually also go another way. We could also specify the position. So one option would be to specify the progress in percent, and there is some questions, and the other option would be to specify to just give a position and a total, and then the position progress can be calculated. Let's see. So there's a question about the assets. Why use them over simple if statements, or actually exception handling? A if statement or an exception will always be triggered in a debug and in a release build. The idea of asserts is that they only work when you have a debug build. So if you're debugging something, you will be notified about events happening, as you saw with this window that popped up. While if you have a release build, the error condition, let's say, will be silent. It will allow the program to continue as good as it can. And usually you will want to have asserts for things which might not necessarily be breaking but just are unexpected, so that you can then investigate why something unexpected happened, while for the production build you would want the program to keep working as there is no debug attached anyway. So an assert when written in a production build would just crash the application. Okay, but let's continue with our progress signal. So we will have a position, a total, and a string in the file name. Oops. Right. So let's go to our session, and whenever we read something from the buffer, or whenever we write something to the socket, we should go with the writing socket. So if we managed to send something, then we will here emit, or actually that probably will not be the fastest implementation, because we'll do it like multiple times. So better would be to cache this. So yeah, but for the socket we don't have the position. Okay, let's go with the file. We will just emit a progress event. Right, and for writing we'll just do the same thing from wherever we write the file. Write, but here we don't have like multiple iterations, so we can just directly emit a progress information here. And in our message we need a slot for that. Let's just we of course need to know from where this has been sent. So again here get the sender information to get the right chat session, and we will add here a queue map chat session queue stern labels. And of course now we need to add some labels to our status bar. So on the file offered. So if we accept the file, then we can add insert chat data, comma, label, add widget, label. So we add a widget to our status bar. We set it here that we will be able to access it. We also want to do the same thing here before we say send file. And then whenever this happens, we will be just retrieving our label from our labels. And if executing does, then return else set text type %1 %2 %3 split 2 file name comma separator is this one comma and reverse is true, and we want the second, so we just want the file name without the whole path, and here we just specify pause and total. And we should probably also say whether we are sending or receiving, but for now this already will be enough. And also we want to get rid of that once the session closes. On tab changed, we had somewhere, I think, a onChat ended. Right. If the chat session ended, then we can get rid of our label. Alright, take. Use the take function so that will be removed from the list. Okay, let's try it out. Oops. Chat. New chat. Wait. No, we want a tab. That's, the name is misleading. That should be just chat, not the new chat. Quite right. Punkt. Get session. No, it's fine. We might want at some point to improve our nomenclature because it's slightly inconsistent. So we are calling different things a chat, and we should not do that. That is just confusing. Send file. Again, we go to our big test file. Yes. 2. And it's not working. So it created the 2 entries, but we are not getting any events in our on progress. Oh, I think I know why. Wait. Because we forgot to connect it. Did we really forget to connect it? Apparently. Let's quickly delete the test file. Yeah, we just forgot to connect it. Well, that happens. This comma with chat, comma, chat is of type picture read to data. Right, and the other one was here. Chat, but again here chat session. Right, okay, let's run. Oops. Right, I need to add this end marker since these are not static functions. That was not the file I wanted to send. That one. Okay. Why? It complains that it doesn't not find the signal. So connector center. Oh. Wait, right. One moment. Send a small case of first typing, then thinking. Wait. Sender and then the receiver. Oops, too much, comma. Okay, just overwrite the existing file. Okay. So one is working, the other label is not. Then we need to check out why the other label is not working as we expected. So let's pause this quickly. We could put a breakpoint here. Call stack and come at some point to our okay, so we get a lot of from ready read, a lot of notifications, but somehow from here we don't get any. Yeah, so what happened is that we kind of put everything. Also there was a small bug in the display here. I think we just put everything in the cache and then it's just emptying the cache, so this is not ideal. Plus here the other one, this one, it shouldn't use file size but usize, otherwise we will not know how far to go. Right, so this one is working, this one is not. So what I assume happened is that here we are either locking up, which wouldn't be good. So now we will just run it with this breakpoint and see how this loop behaves. And then we will know more. So we start the chat, send the file, messenger. Also, we should probably reduce the rate at which we are updating the UI, otherwise this slows everything down. So we start here, we read 4 kilobytes successfully. We ensure the buffer knows that it's the size that it has. Then we try to write. Manage to send all the 6 kilobytes. Well, and then the question is whether at some point we will break here or not. We broke out because we finished reading the file. So what happened is we really stuck like everything there was into the buffer of the socket, and the socket just accepted everything. So we probably should somewhere change the buffer size for the socket so that it will properly fail after a certain size. We don't want this set to just accept anything forever, because this will not be great. So for a file that's just a few hundred megabytes, it's fine, but if you have a file that's a few gigabytes in size, then that will be a problem for your available memory. Start send file. So somewhere here, set, but there's only read buffer size. Let's see what this socket option does. One moment, please. Okay, so set socket options. Well, here we can set, but this looks like it's more a preset for the underlying Windows Windows socket. We would want to disable the buffering at the level of the I/O device. That might be difficult, but it should be possible somewhere. So the thing is, we can specify an unbuffered flag when opening a device, but since we have also here incoming connections, this means that we cannot set that. I mean, we could manually probably just implement a manual limit. So let's see, bytes to write. Bytes to write will give us how many bytes there are to be written, and we could have here a special case. So if bytes to write is more than, let's go with how much? Let's go with a megabyte. So if we have cached 1 megabyte, we will break out of this function, and then here we will emit our progress, and then we'll return here once we have sent something on bytes written from this function here. That should work nice. I'm sure there is a better way of doing that, but that's just a quick and dirty solution to not overwhelm our buffers. Not great, it just sent a megabyte and then it failed. Is this slot not working? Let's put a breakpoint here and try again. Oh, but we need to restart it. Yeah, we get an unwritten notification when we are sending normal data around, so it's strange that it wouldn't be working. When we're actually sending bulk data. So we have here, then we enter here, and then should come back there, right? That is fine. Bytes written. We don't want to go into that, we just want to step over it. So we read something extra. We break out again, and we should come back again into here, and we do. That seems to behave correctly. But it still failed at some point. Surely it failed quite exactly after sending 1 megabyte. Let's debug that. And each time we each time we send something, we will also write a line. Okay. Well, it triggered a lot of on bytes written. For a good portion of time it was sending, but then it just stopped. Oh, perhaps that could be. I haven't checked the documentation of the bytes to write function. No, but it's pretty clear that these are the bytes which have to be written. So if it invoked this function so often, it should resume writing, but it did not. Oops. And also here this kind of still didn't properly display in the right label, but that's a unrelated issue. Where it enters here, so either P file has been closed already. Right, I know what's going on. So the check here is at the wrong position because we have an empty buffer, and then we still break out of it. So what we would want to do is we want to read the next portion into the buffer, and then we want to break out if there is too much before we try sending. The problem was we have been hitting this case here, and our file then ensured that we never re-entered our onBytesWritten function. So that should solve that. Zack, zack, zack. Yes. Well, it's sending and it's continuing, so it's working. The only question is why is this here not properly displaying the data? Well, it should be label it's not. We always get it from ready read. I think there is some connect error still with this function. So ready read, so this is the receiving end. So the receiving end, the one file offered, this end works fine. The other end, the sending end, does not. This side is failing because here we get a sent file. That's the problem. We are connecting to the wrong element. So here we will, for send file, change the return parameter. So that we know which element. Actually, we could change both because that would be nice for start chat as well, to get the newly created object out. Right, and here we need to get the return value. I'll just call it file chat for expedience. So now that should work and show both. And we should also probably change it such that when we are offering a file, we are only sending the name of the file and not the full path. But it's a minor optimization. We don't need to do this right now. Darn it, it still doesn't work. Wait, but now we only see the sender, the receiving side. We still just see the receiving side, we don't see the sending side. The sending side is here, so we get the file chat, send file. But we don't get an error because of connecting. That is odd. File chat, send file. Here session start. Yep, it looks correct, but for some reason it is not. So here we emit the event, that is fine. But for some reason the event is not being... we finished the file transfer, so let's send again a file. Right, we are trying to emit it, that should be fine, but somehow here the onProgress is always only triggered from the... Actually, now we were triggered from the right... Oh, I know. We also, of course, need to change this this line. So we were triggering the slot now correctly, but we simply were not finding the right label to put our data into. And voila, we now have both progresses shown. And once the transfers are done, both labels will be removed. I hope. Let's see if this works out properly. So we have here our onChat end that should be called twice once we are done. It takes a moment. We should maybe in future take smaller files for testing. Also, as you might notice, it is kind of significantly slower than it was at the beginning. The reason will be that we probably just have too much events which we are generating. So what we will want to do is to limit the rate somewhat. We are almost done. Right, one. It only happened once, so we did not receive a close signal for the other one. But imagine that worked already before both were cleared, so we need to debug this as well. Also, as I said, we want to add some rate limiting for the progress events, so let's be more... doesn't matter, let's go with this one. Last progress update. So... actually, I can do it better. Elapsed timer. Need to start this somewhere. Then we'll be resetting that regularly. Right here, when we open the file, we can also create the timer and start it. If elapsed timer elapsed is more than 1 second, then emit and restart. So now it should send data only once per second. We could improve that such that it will not that will like always issue the last update. But since we expect the notification object, whether that be the status bar or a window, to go away once the transfer is finished, so I think we don't need to send the last update, since then it will not be visible anyways. See, it's updating now once per second, and it's much faster. although, okay, and we failed to close the second one. Also, updating once per second doesn't feel snappy enough, so let's go with 10 times per second. This should not make it considerably slower. The question is why the close doesn't work. So on disconnect, we'll put a breakpoint here so that we can inspect both events if they trigger a on disconnect event, which I think they will. I assume the issue is probably that we forgot to connect one of the close events further down the line on one of the ends of the communication. Oops, I selected the file number 2, so let's just make a file number 3 out of it. Yeah, that 10 times per second feels snappy enough. And it is still reasonably fast. Interesting, we didn't have any disconnect events. That's unexpected. This means that we close from another end. That would somehow... Right, so we make here a close, but we don't close the socket, that's the problem. Because close is a... Yeah, we need to be a bit more systematic about what we are doing. So, on disconnect should emit closed, should not make close, and close should close the current socket. Actually, it doesn't even need to emit this, so mp socket, close socket. So the socket will be closed, and then the on disconnect will then automatically trigger the other events. So let's now quickly try it out. Yeah, it's still working as expected. Slack, chat, send message. I mean, now we could really select a smaller file, but since we always tested with this one, we could select a slightly smaller file so that we still have some amount of data to transfer, but not as many. Okay. We ran into an issue. The thing is, we are disposing of the chat session too early. And we are doing this because we are disposing of it instantly when the last smart pointer gets disposed. So we somehow will need to improve on that. I will add a destructor, an explicit destructor here, so that we can put a breakpoint on it and see from where this happens, and then we need to think at the breakpoint how to avoid the instant destruction of our object. So usually Qt gives you this delete later operation, but this delete later does not work in scenarios where you use smart pointers. So there, as soon as the pointer goes out of scope, it will trigger an instant delete, and this is what is being problematic for us right now, as far as I can tell. Right, so here we want to dispose of it instantly, and this is not good. On session close. Right, because we are removing the file session here, and at this point the last reference to this element goes away. So first of all, we will make a we already have a smart pointer, so this should be fine enough. So remove should work okay. We just want to hold on to the pointer slightly longer. Um, interval 10, comma, slot reference. Right, if we want to capture this punkt. Just this. That is a bit hacky, but it should solve the issue. So what we are doing here basically is we are creating a lambda it cannot change it because it's by value. That is not good. So when capturing by value, we can only read the variables, we cannot write to them. We could try what happens if we really don't do anything, but I don't think it's smart enough. So what we want to do is basically want to create a temporary smart pointer, which will be captured in for a lambda function, and as soon as the lambda function, which it will be triggered by a single shot timer, finishes, then we want the pointer to be deleted. So this is a bit a hacky solution, but it should work, and if it works as expected, it should be quite reliable. Alright, so here we it could be right. Then we distract it. Yeah, it is working. One could think of some more elegant solution to this issue, but this solution here is already good enough. I will just move it one slower so that we always do it. So this deserves a comment because it's a strange thing to do. So oh, I have another idea. I have another idea. If we know that this is the last instance, well, but we don't, that's the problem. So what we could do is we could check if this is the last instance. Maybe we can 2-week reference, no, or reset, no, we can. It will not tell us how many instances. So the other option would be with some smart pointers you can detach or release. Somehow get a reference, the actual raw pointer out, and then at the same time without triggering a distraction of it. But apparently the Qt smart pointers don't support that. So if we could do this, what we could have done was would have been that we then just detach it from the smart pointer and then use delete later. But then of course we would need to be sure at this point that there are no other smart pointers pointing to this element. So our hacky solution here is probably good enough for the long run. Okay, so it is working. It is working quite nicely. So now let's look into the homework for the next lecture. So from the 07/12/2023 probably Note the transfer. Progress AQ progress bar. It should the transfer is done, the um, optional. Okay, any questions? So the homework will be to implement a dialog box which will show the transfer progress. So effectively, if we are testing a communication with our own instance, then we will have two dialogues popping up. And the idea is that you will see who is transferring the file, what's the file name, what's the file size, and of course the progress. And there is an optional assignment for this homework. You could implement a cancel button, so if you press it, it should just close the socket. You could of course implement maybe some more sophisticated mechanism, but given that our communication is so basic, then I think closing socket is the only safe option. Yeah. That's that. Okay, what else could we do in the short time that we have? We have just 15 more minutes. We could already start thinking of a final project assignment for the lecture. So I would say we will fix that during the next lecture, but now I will already give you my thoughts on what would be a nice thing. That would be a self-written text editor application. So it is not super difficult, because you just need to create an own dialog which will contain an own text field, and then implement an own menu, an own toolbar with save as, open, etc. You can use AQ text edit for to render the text. So this is quite easy, but there will be a lot of like small things, like a context menu for the text edit, so that you can search, so that you can copy and paste, of course, but also search for text. So this will be a bit more sophisticated already. That you need you will need to implement a search function, and then as well as a search and replace function. And then I will also think about some other convenient functions which a text editor should have. I think this is quite a good approach to get used to making new Qt UIs on your very own. It is not too complicated and does not require any more complicated, more sophisticated back-end work. I will try to think about some additional features which might be useful for a text editor as optional assignments. So one thing, for example, which would be good would be the ability to download a file of the internet. So let's quickly start a short idea. So text editor, status, maybe it was called QPlain text edit, I don't remember. Okay, search and replace functionality. What else would be needed? Open /download This is actually quite easy because there is a class from Qt, QNetwork. Was QNetwork Request Manager? I think it was QNetwork Request Manager, which implements you the functionality which is required to download files using the HTTP protocol. I think at some point it supported FTP as well, but FTP is not really used anymore, so it's enough if the tool can only handle HTTP paths, and you don't need to take care yourself of the HTTP header encoding, compression, etc. The class set around QNetwork Request Manager does all of that on its own. So you only need to start a request, provide a URL, and it will download you the file, which you can then render in the UI, and of course saving will be only local. Another thing which would be nice, I think, would be to have a built-in calculator. Calculators are usually quite useful, and if you're writing some things, then it might also be good. One thing that would be generally nice when thinking about writing own text editors would be to have some sort of support for writing program code. There is a option for implementing a syntax highlighting in Qt, but I think this might be like just highlighting without other features is probably not great, so I will not write this down as an optional feature. If you want to add it, you can, but I don't think we will need that. I will think about some other things that one could also have in a text editor, which would generally be useful. I mean, there are many like small quality of life improvements, like like a hotkey to convert the selected text to upper and lowercase. As an optional assignment, we could add open and save different encodings like UTF-8, etc. So this is also quite useful if you can change encodings between files. Of course, searching, as mentioned, is useful. The thing needs to support undo, so there is for Qt a mechanism how you can use this with the, I think it's a QTextEdit. I think there is a more advanced control as well, which might be easier, but that will be for up to you to find. Status bar should show file size, comma encoding, comma current position. Current position, yeah. Current column, comma selected length, etc. Well, there is not much, etc. That's pretty much it. Menu bar and toolbar, which optionally could be customizable. So for we've selected menu options. Right, icons, they are free there, so you just go there. You can download without an account and search by name for whatever icons you might want to have. One more thing about the final project. So if you want to do something else, then you are free to make a suggestion what you would like to implement instead of the recommended final project. Of course, it needs to be something that will be at least as difficult. Suggesting less complicated things is kind of not the point. But maybe you want to implement something that is useful for you already in some lab application, or there was something you always wanted to implement, and now you have the opportunity to do so. So the idea simply is that you can, if you present this project during the next lecture, do it instead of this if I deemed it complex enough. Right. Anything else about the functionality we might want in a advanced text editor? Let's quickly take a look. So for example, we have here Notepad 2, which is quite a nice editor. It has a lot of options. It also has like a menu which you can show. View. It has quite a few settings. Also, but you don't, of course, need most of them. But word wrap would be good. Word wrapping is good to have. Oh, and the go-to option is also good to have. This is quite useful if you have some source code and the compiler tells you error in line 120 something, then you could go to the line. Although when I think about it, I don't think Qt has a line gives you the option to directly select a line. So let's do this an advanced optional assignment. Add go to line column option as well as optional, as well as the optional line number display. So this is of course nice to have a line number next to your line, but let's make this optional. And I think this will be it for today. I will upload the updated QMessenger source code to Moodle as well as the homework assignment. You can think in the meantime about the final project if you have any ideas, any questions, any suggestions, etc. During the next lecture we will finally decide on what will be your final project, and then you will have time until the end of the semester to implement that, which will be an important part in your grading. So since tomorrow is a holiday, then have a nice weekend and we will see each other next week. Bye bye.